Hi everyone. In this example, we'll be looking at a problem that deals with circles, triangle properties, and polar coordinates on the SAT Math section. It's a bit of a complex problem, but once we break down all the steps, you'll see exactly how to solve a problem like this. Specifically, it's question number 19 from the No Calc section of official practice test number 1. And so if we look at the diagram and read this question, it says, in the xy plane above, O is the center of the circle, and the measure of angle AOB is pi over a radians. What is the value of A? So to solve this problem, what you have to first do is use the information that they gave us to try to construct a way to solve this problem. So they gave us that the measure of angle AOB is pi over a radians, which means that we're going to have to somehow figure out a way to get the angle, or to get the measure of this angle. So what I'm going to start by doing is by looking at this coordinate that they gave us in the diagram, which says square root of 3 comma 1. And it looks like we have like this triangle shape with this angle that they've given us. So immediately when I recognize this, I want to figure out a way that I can use a right angle or some kind of like a right triangle to get values. So what I'm going to do is I'm going to create a right triangle just based off of what they gave us. And I'm going to start constructing some values. So they gave us that the x-coordinate is root 3, which means that this length right here at the bottom is going to be equal to root 3. And they also gave us that the y-coordinate is 1, which means that this part of the triangle right here is going to be equal to 1. Which means that now that they gave us these values, and since this is a right angle, I can find out the hypotenuse. So that's going to be root 3 squared plus 1 squared, which is equal to 4. And that's going to be equal to c squared, the hypotenuse. So this hypotenuse is now equal to 2. So now if I draw this triangle down below on this triangle I have here, I now have root 3, 1, and 2. And if you know your triangle properties, you'll recognize something here. If I take a triangle and I have a 30, 60, 90 triangle, so my right angle, 60 degrees, and then 30 degrees. Let me just make that a little bit more clear. 30 degrees. Then my sides are going to be x root 3, and 2x, where x is any kind of constant. And that's exactly what we have here. In this case, x is 1. We have our x on the bottom, we have our x root 3 times 1, and we have our 2x, which is just 2 times 1. Which means I can now fill in the angles here. I now have our 90 degree angle, my 60 degree angle for the x part, and then my 30 degree angle on the top. Which means I now know what angle AOB is, and if I match up the triangles, I now know that angle AOB is equal to 30 degrees, which I'm going to write down here. But we're not done. In this question, they're not asking for the angle in degrees, they're asking for it in radians, which means I now have to make a conversion. So now if you know your radian conversions, you'll know that 2 pi radians is equal to 360 degrees. And if you forgot this, you can just look at the front page on the formula sheet, and this will be there. But I think this is very helpful to just know on the top of your head. So I now have 2 pi equals 360 degrees, which means that I know that this angle is equal to 30 degrees, so I can just set up a ratio. So I have 2 pi over 360 degrees is equal to some value x, which I have to figure out, which is equal to 30 degrees, which is the angle that we found. So if I cross multiply everything, I get 60 pi. 60 pi is equal to 360 degrees times x. I'm going to take out the degrees actually for now, so everything is constant. And so now if I divide everything by 360, I get x is equal to pi over 6. And if we look at the form that they gave us, they said this angle is equal to pi over a radians. And so that means that in this case, a is equal to 6. So once again, this problem is a bit complex, but if you can just break everything down, start with what they gave you in the diagram and look for patterns, and obviously know all your formulas related to circles and triangle properties, you should be good to go. We'll see you in the next video. Thank you for watching, and have a good day.